Hello friend, I am Naren, your host. Today I am back with another video. In this video, we're gonna talk about Terraform Statefile. When you are creating any AWS resource or any resource using a Terraform manages all those resources in the state file. What is the state files? Terraform state files is a JSON file where it keep record of all your resource that was created by the Terraform. You can think about Terraform state file is like an inventory list. If you do not have the Terraform state file, Terraform does not know what are the resource exist or what are the resource you have created. And it's also doesn't know the current attribute of your resources, like instance ID, IP addresses, and relationship or dependency of between your resources. So in order to aware about what has been created by you, Terraform store all this information in the state file. What is the purpose of this state file? Now, state file is used to track the resource. All the resource that you are creating from the Terraform, it can be tracked by the state file. Speed execution. Since Terraform store all the resource information, so retrieving infrastructure information is very easy as Terraform managing the state file, so your execution will be faster. Compare current and desired state. Since all the information is stored in the state file, so when you are running a apply command multiple time, Terraform will comparing the current state and the desired state. If Terraform found any mismatch during the comparison, then Terraform will help to recreate or create the resources on the cloud, whether it is in the AWS cloud, Google cloud, or Azure cloud, or any other kind of the provider that you are using in the Terraform. Now, it's also stored the metadata. When you are storing all the information, Terraform also store the metadata of your resources. Now, key fact of the state file. Now, when you are executing a script using Terraform, and Terraform run that script and launch the resource, then Terraform automatically create a terraform.tfstate. So your tfstate name by default is terraform.tfstate, and its format is JSON file, and you can store it in on the local folder or the remote backend like S3, Terraform Cloud, etc. Sensitive data can be stored secrets, so protected, it means encryption restriction access. Terraform can help you to store the secret information and also can help to protect with the encryption. One thing is important here: when you are manually working on the state file, never ever edit Terraform state file manually unless you are absolutely know what you are doing. Otherwise, if you are don't know what you are doing and you manually edit the state file, you will create a problem. Meaning, like, if you corrupt the state file, then all the existing resource that was created by the will no longer Terraform will no longer handle them easily. Or maybe you will found that you get stuck and you have to perform the whole operation manually, whether it's like removing the existing resource that created by the Terraform. So it's recommended to not edit state file manually. Now, why state file is required by the Terraform? See, without the state file, Terraform would have no memory of what it has already created, or you are at risk. So, duplicate resources. orphan infrastructure, wrong update and delete. So all these kind of the problems that you may face if you do not have the state files. So that's why Terraform come with the very great feature, like it it can manage the resource using the state files. Now, as we previously in the previous slide we have discussed, like you can store the uh, Terraform state file locally or remotely. So we have two types of state files: local state files and remote state files. So let's take a comparison on those two files. Storage location. Of course, when you are saying if you are using local state file, it will be stored locally on your machine, and its default name is terraform.tfstate. If you're using the remote state, then it will be the state file is stored in the remote backend. Remote backend can be anything like S3 bucket, Azure blob, GCS, Terraform Cloud, and so many. When we're talking about the collaboration, local state is not good for teams. It's good for the single user. If multiple users working on the local state file, then conflict might be happened since the other user doesn't know what you have changed. Since all the user handling their state file in the local, so whatever the state file exists in the local machine, that will be treated as the final state file. So collaboration on the local state file is not good. It's only for the single user. If you store the state file remotely, then it's a great collaboration since you are storing your state file as a central shared location, and it can be great for the team to working on remote state files. So if you are a team of 4 people or more than 2 people, then it's recommended that you can go for the remote state instead of the local. But if you are only the one in your team, go for the local state because it's the faster. Locking system. Locking system is nothing but like when more than 2 people are working on the same task, then the Terraform has a locking facility, meaning if I am executing apply command, Terraform help us to lock my apply command and block the other user to apply again. So for local state file, there is no locking facility because, as I said, it's great for the single user. So probably only one user working on the local state file. So locking is not really inbuilt blocking, inbuilt implemented. But for the remote state, since it's a team collaboration state file, support locking. Either via DynamoDB in AWS, or you may be using the native locking support. Security is local state has a less security since it's for the single user and it's easy to losing the state file. But for the remote state, security is the first priority, and you can also use the encryption. Performance, of course, a local state file is better when we talk about the execution, since you are executing everything locally. For remote state, it will be slightly slowed down, but it is still good. I would say very good, but it's slightly slowed down due to the network, because we have to, when we are storing or retrieving the data from the state file remotely, then we have to call the network APIs, and that part might be slow down your performance. Now, okay, we talked too much about the state files, and if you have a question about the state files, you can write your comment in the comment section, and I'll get back to you on this. So now it's a demo time. Let's move to our VS Code Studio to discuss more about this part. So here is my VS Studio code, and I already created a project called Statefile. Now this is the very simple project. In this project we are creating VPC in AWS Cloud. And here we have four files: main, output.tf, output.tf. We are printing the instance ID. Pretty much instance we are, yeah, we are also creating the instance. So we have the output in the instance ID, and we are also copied the VPC ID. And then we have a provider. In the provider we have to mention the remote backend. Since first we will talk about the local state, and then we will move to the remote state. Okay, and this project is fully dynamic, so I have created a variable.tf with the default value. So you can see here is the default value of this variable in the variable.tf file. And apart from this, I also create a readme file for you to use this. This will help you to directly refer the readme file when you are start working on this. Okay, so one thing I would mention here, that when we are working on S3 plus native state locking, in this demo we are only using the S3 backend. Okay, although we can also support uh, other remote feature like Azure, Google Cloud, and Terraform Cloud, but in this demo we are only focusing on AWS. Okay, and in AWS we are using S3 as our backend. And when you are using S3 plus native state locking, then you can use this parameter. We will discuss in the demo. So first let's talk about our demo for the local state file. So let's run the command terraform init. Whenever you create a new project, you have to run the command terraform init. This is, no, we have to go to the folder first. We have the folder called state file, and then you can go to the state file. Now you can run terraform init. This will initialize the backend. In this case we did not specify the backend in our script, so it will be creating the local backend. It will consider as a backend as a local. Okay, and then it will be downloading the provider plugin. In this case we are using AWS provider. Version is any version, latest of course, any latest version greater than 5.0. Okay, so when we are running this terraform init command, it will be downloading, it will be helping us to downloading the provider plugin, and you can see it has downloaded 5.100.0 version, and the downloading has been done successfully. So you can see we have two files here, the log file and the terraform folder, but still the state file is not appear here. So what we can do is we can run the terraform plan command. Now terraform plan command generally check generally read our script and make a plan or make a list of resource that we are going to create on AWS. Resource, by running terraform plan, resource will not create it, but it will give us a list of resource that is going to be created. To create the list of resource, we have to apply terraform apply command. So you can see we have the 14 resource to add, and still we do not have the terraform state file appear. So now let's run terraform apply, and there is a flag auto approve. This flag will help us to avoid the user configuration. Now you can see there is a file called terraform.tfstate file appeared, and also we have a log info. That means we are using the higher version. We are using a higher version of HashiCorp or TerraGrant that has the native support of locking by creating a file. In the readme file I also mentioned that one, that you can see Terraform attempt to create a lock file with the tf lock extension next to your state file in S3. If no such file exists, S3 create it, otherwise it return error. So let's go to check, and our resource has been created. We successfully created a private VPC that is called the virtual private cloud, and we deploy one instance in that in our private virtual private cloud. Now let's take a look of our TF state. Now you can see this is the JSON format, and it will be store all the data that we are using. Version 4 Terraform version is this, serial is this, output is this. Since we mentioned the two variable in the output, so it will be listed the output here, and the resource here you can see these are the resource that we are creating, and it create the instance. And then so you can see here is like IZ, all are the resources that we have created are mentioned. It's very hard to understand. TF file is very hard to understand by user, because if you are really expert then you can understand this JSON file, but for the beginner it's okay to not understand, because the Terraform manage it automatically, and as a beginner you should not touch this file. Okay, now what we will do, we will see how we can create a state file remotely. So before creating on the remote, we have to destroy the data, the resource we have created. So let's run destroy command. Destroy command. When you destroy the infrastructure, then Terraform also update the state file accordingly. So after the destroyed, we will see how the state file looks like. Okay, so let's wait for it. Will asking for the confirmation. We say yes, you can destroy everything that you have created. Now it will be very quick. Within a minute it will be destroy all the resource, all the 14 resource. So that is the great about the Terraform, that you can create the resource quickly and also destroy them quickly. Now let's wait for the resource to destroy, and it will pretty much done. Now after destroy, you can see we have a backup file. Like you destroyed the resource, but we have generated a backup file. This backup file is nothing but is all your resource that has been created previously before you destroy. So we will keep the backup file. Also the Terraform automatically create the backup file. Now if once it will be done, then it will be, what's wrong here, it's saying it is still okay. All the resource has been destroyed. So now you can see we have the Terraform state file. It's pretty much empty. That means no output, no resource, nothing. All the basic information. That means we have successfully destroyed all resource, and now our state file is pointing no resource. Okay, now let's remove this state file. We don't need it. We remove this state file, and also let's keep this log file as it is. Now we have to go in the provider.tf file. First we will check s3 plus. First we will use a remote state file in using s3 plus DynamoDB. So let's uncomment this part, and then, but in the DynamoDB, before you are using the DynamoDB, make sure that Terraform logs is exist. This is the table name which we are going to use to store the locking feature, right? So what we can do is we can go to readme file, and then we have a command called the AWS DynamoDB create tables. You can copy the command. Since we are running the AWS command, meaning we are running AWS CLI, make sure you have download the AWS CLI and configure your client ID and the secret ID. Let's know this one. Let's copy again and then we can paste it. Now as soon as you enter the as soon as you press the enter, it will be create 1 DB in the AWS console. Let's check. We are already in the DynamoDB. Refresh it. The command may throw the error if you do not have the permission. So you can add the DynamoDB full access permission in order to create a table in DynamoDB. Once the table is created, you can see it is inactive. Now we have created the tables and we also enabled our backend. We want to store in S3 bucket. So we have also created this S3 bucket. You have, before you using this, you have to create this S3 bucket. Okay, so I have already created this S3 bucket, and once you created S3 bucket, okay, we have created S3 bucket here, and then you can specify. Okay, so we have already created the S3 bucket here. So you can also create S3 bucket with your bucket name, and once you create that, you can add the bucket name here. Now key is nothing but where you want to store, what is the path of your state file. So because I'm developing, so let's say I create a dev folder under this bucket, and inside the dev folder I want to store my terraform.tf file. Now this is the region. Now region, where is your bucket. So my bucket is in US East 1 region, and this is my table. I already created the table via the command line. Now let's save the files, and we are going to run the Terraform plan. Terraform, or maybe we can run directly Terraform apply with auto approve. Wow. Okay, it's saying that you have changed the backend configuration, so Terraform init command is required in order to initialize the backend. And in the previous, when we are discussing local state, then you can see we run the Terraform init, it doing the two tasks, initializing the backend and then in downloading the cloud provider. So it's saying we are enable the backend, but you are missing to initialize the backend. So we have to run terraform init command. Now let's terraform init command. As you can see, it's initializing the backend. So backend initialization has been completed using S3, and init is successfully done. So now we can run the terraform apply auto approve, and when you now you can see it did not created the state file locally. So if the state file locally is not created, meaning the state file exists on your S3 bucket. So let's go to our S3 option on the AWS. Now you can go to here in S3 management console, and I am on the US East 1, and here is my S3 bucket. Now you can see a dev folder is appeared. So you can go inside the dev folder, and here is the TF state exist. So meaning we successfully created this TF state on the S3 management and S3 bucket. So this is how it's working, and all the 14 resource has been created successfully. Now if you open this TF state file, So let's open the test files. You can see all the information in exist in this local tf in remote state file. So these are the data that Terraform fetch it from all the resources that you created. Now let's go back. We can close this one, and one more thing, we can check the DynamoDB, that is there any entry or something in the DynamoDB. So no active alarm, no table stresses active, indexing not quite sure, but that's fine. We don't care about this because this is how the Terraform will automatically manage this. Now let's run the destroy command to destroy all the destroy command. Now let's destroy all the resources that created by us, and then we will change the backend again with native locking support. Okay, it will take some time, and in this meantime, when we are working on native locking support, we do not need a DynamoDB table. Terraform will managing the native locking by creating a file next to the state file. This is what the document says. We can verify this. So let's say we have this table, we have to remove our table after this destroy done. So it will take some time, so you can wait for some time. And I have mentioned all the information in a readme file. You can also copy your backend code if you want. And for the use S3 plus native state locking, you need to use this property. This property will ensure the native lock will support it. Then you can copy this code in case of you want to use the native locking support. Okay, then let's check. Oh, is this still destroying the resources? So we have to wait until this destroy action is not done. Voila, destroy has been done successfully. So now let's say we run the create table, so we can remove all the things, and we have to remove the table as well. We don't need this table for the native locking support, so we can say delete table and then enter. So this will help you to delete the table. Let's verify whether the table is deleted or not. It's active. Now when you refresh, you will say the table has been gone, and you can see 0 table. Great, this is what we are wanting, right? So now let's disable this part. We don't want to be create DynamoDB. We don't want to be use DynamoDB for locking, but we want to use native locking support, and encryption is true based on your requirement. And in this case, let's say we can keep the folder same. Okay, so we can have this bucket name will be the same, and then inside the buckets we should have a dev folder, and inside the dev folder we have the tf state. Okay, now but before we running the terraform command again, let's go to the tf state files inside the dev folder. Now let's take a look. We will open this state file and see what are the content. So meaning the state file is empty now. You have no resource, no output, meaning the state file is empty. That is the expected behavior because we have destroyed all our resources that was created by the terraform apply command. Great. So now we are under in their folder. Okay, now let's try to terraform init. Of course we have to do init again because we changed the backend, so it should be analyze the new backend. Wow, Now this time is a different error. Why different? Because we have changed the backend, right? So the backend setup was or already initialized, and Terraform is smart enough to detect, okay, listen, you have added the new backend, so you have to pass this migration state flag in order to continue with your new changes. So we will copy the command and run it as it is. Then a new backend is saying backend configuration changed. Terraform has detected that the configuration is specified, the backend, right, has changed. So a new backend has been initialized. Now let's run Terraform apply again, and of course we will auto approve, so it will not ask command prompt to confirm. Then we are creating the resources again, so it's reading all about the information that is wanted to create. And then if you go to the project, still there is no terraform.tfstate, and that is the expected behavior because we are storing the state file on the remote backend, and this time using a log file that is nothing but a native support logging system. And this native support logging system, introducing in Terraform 1.10. Okay, so all the higher version than 1.10 will have this feature. Now the resource is creating. Now it's, as it's saying, it's creating the log file near to the state file, so we have to refresh it and see whether it's created or not. I'm not quite sure that part, but all the resource has been completed successfully. So let's go out. We don't have any log file, but it's okay if it is, because since we are only the one user, so maybe it's not creating the log file. But let's take a look about the state file. We can open the state file here. Now you can see we have the same similar kind of output previously, but this time without the DynamoDB. Okay, so that's all. But before I stop the recording, let's destroy it again, because I don't want to be keep all the resource, so we will going to destroy. And that's all for this video. If you like my video, please do subscribe my channels, click on the like button, and if you have suggestion, comments, please use the comment box to write your personal comment. Thank you for watching my video. Have a great day and see you in the next video.